Okay, so operational excellence. Okay, so operational excellence. All right, so here's the goals. I'm trying to make sure I'm recording it. Hold on. Oh, Zoom recording. Okay. Start video. All right. So chapter goals. So first thing is going to be to describe a process, identify waste. After you know what a process is, you have to be able to determine whether their process is actually working. Okay, some simple tools in Lean and Six Sigma improvement. What is Six Sigma and what's Lean manufacturing is really what I'm going after here. Okay, now this picture is from the book, and I don't need to go over all of this with you because you guys can read it. But the idea is to try to show you all the different components in biotechnology. Okay, so there's R&D, there's making the drug, there's quality assurance, there's clinical research testing the drug, and then there's all the other stuff that has to go on to support the science to make sure that everything is working right. The company is making money and is safe, right? Okay, so now operational excellence is OEX or OPEX. So this is a business philosophy. Okay, so I am not an expert on this. I give you one lecture on it. I think we even have whole classes on it, and you can take classes online or if you work for a company and you're going to go into management. Okay, so the idea is that we're going to have an excellent company because we're going to be continually improving. Okay, so it's a data-driven process that's going to improve efficiency and save money, okay? And that's how they're going to achieve excellence. Okay, so the goal of operational excellence is to provide a quality product that meets or exceeds the customer's expectations. So the customer's got to be willing to pay for it. Okay, so operational excellence has been around for a really, really long time, but they didn't necessarily call it that. So they believe that it started in China and ancient Greece and Rome. So when one of the first examples of it was when they were making bricks for buildings, and people would bring the bricks to sell, or they would be living at where they were building, right? And they wanted to be able to identify who was making the good bricks and who was making the poor bricks. So they developed a way to stamp the bricks in order to punish the poor brick makers. So it's like a maker's mark on it. So China had laws for quality control, standards, measurements, traceability. Okay, so all that is going to be important. Okay, so in the 1900s, Frederick Taylor used data as a tool to improve. He said, let's look at the data and let's try to figure out where the mistakes are and try to improve it. Okay, and then Bell Labs, if you guys watch Miss Maisel, her dad worked for Bell Labs. Okay, so it's invention labs. So they use statistics, so it's math-based to improve quality. And what they used was called acceptance sampling. So you look at a statistically significant number of products to make sure they function correctly. And so if you pull out some random samples and you have a certain number, then in theory you can know how good the batch actually is. The Japanese have cause and effect diagrams. Okay, so some operational excellence programs are TQM, which is called Total Quality Management. There's re-engineering, Six Sigma, Toyota production systems, lean manufacturing. And there are all sorts of certifications that can be earned. I don't know why I have the bottom of these slides cut off. Okay, so some places provide belts. So it's like a black belt or a green belt, depending. So those are going to be things that are individual based. And organizations, so whole companies, can be certified too. So ISO 9000 is an example. Okay, so one example, if you've ever worked in any sort of manufacturing, you have probably experienced this. So a scorecard, or even like Citibank will use this kind of thing. So a balanced scorecard, it's one way to evaluate whether a group is meeting their goals. Okay, so we have all these different metrics, and then we have first quarter, second quarter, third quarter, fourth quarter, and you can look at it, you can say, oh, look, we're making the revenue that we're supposed to be at, but we're not, our income is flat, right? We haven't come up with any new products. Okay, so it's just a name that put onto things that companies usually do anyhow. Okay, so a process is what's going to be measured. Okay, so these are activities done in a particular order to achieve a desired outcome. Okay, so we want our processes to be efficient, not inefficient. What can lead to inefficiency? There's all sorts of things that can lead to inefficiencies. So things like waste. We're going to talk about that. Okay, so in operational excellence, we want things to be lean. So lean means that there's little waste and that it's going to provide value to the customer. So a waste is any activity that does not add value. Okay, so the purpose of lean manufacturing is to look at the process flow and analyze it and try to eliminate waste in any form. Okay, so typically they want this to come from all employees. Okay, not just top down. Okay, so what somebody that sits in the office and doesn't do the work sees as waste might be essential to somebody that's on the floor doing the work. Okay, so in biomanufacturing, these are some sources of waste. Okay, so and they say it's downtime. Okay, so defects, overproduction, waiting, not utilizing people, transportation, inventory, motion, and extra processing. Okay, now do I have, I thought I had slides for each of these, but I might have took them out. Okay, so defect means it's not, something's broken, right? The product's not any good. Okay, overproduction means you've made more than you can use. Or maybe, well, if you've made more of something than you can use. Okay, waiting means you're waiting for things to come from the step before you, or you're waiting on materials to arrive. Not utilizing people means that maybe you have someone with a PhD driving the forklift, okay, when they would be better utilized in research and development. Okay, so not utilizing people. Transportation means maybe things aren't getting shipped properly, and that might lead to waiting for things. Inventory, okay, so you don't want things to expire before you can use it. You want to make sure you have enough of what you need when you need it. Motion, okay, is you want everything to flow in a good manner. You don't want to be doubling back over and over again because that wastes time. Extra processing, you don't want to be mixing something for 2 hours when 20 minutes would be enough, or you don't want to autoclave it for an hour when 20 minutes is enough. Okay, so all of these things are sources of waste and are going to be things that you look at to streamline and save money. Okay, so value added is anything that the customers are willing to pay for that increase the form or function of the product. Okay, there are some things that we have to do that the people aren't necessarily willing to pay for. So examples are certifications, inspections, things like that. Personally, I'm willing to pay for it. If the FDA is looking at my drug and they're making sure that it's what it's supposed to be, I'm willing to pay for that. Okay, so NVAR is not value added but required. Okay, other things that are non-value added would be things that like you're hanging out and you're waiting because somebody forgot to order it, or maybe like right now the mail is really messed up, right? So we're waiting for materials because all the postal workers somewhere have coronavirus and there's nobody to deliver the mail. Okay, or going back and fixing mistakes. Like you have to fix it and you have to have the materials. It's not adding any value to the product. So this is a value stream map, and I don't know that this is the best example. It's kind of hard to see. I took this picture from the textbook. But the idea is, here's the person that's going to be making dinner. Okay, and what we want for dinner. Okay, they go to the store and there's your shopping list. They do the weekly food shopping and hopefully they have everything that they need. If not, if they have to go back because they didn't have a good list or they couldn't find what they needed, then that's not adding value, right? Okay, so you prepare the food. Okay, then there's little things in here that don't add value. Okay, so maybe you didn't get everything ready at the same time. So one part is sitting, waiting while you're trying to finish the other part. So that's downtime. Okay, so what a company would do is they might take a process and they would track the whole process and look at the time and see where there's downtime and if the downtime could be reduced. Okay, so now one theory about an efficient workplace, and this makes sense, right, is that there's flow and balance. So one tool that lots of manufacturers use, and I see this in biomanufacturing companies, is a Kanban. So it's a visual card, and this is a good example with Post-it notes. Okay. And so here's to do, doing, and done. Okay. So they're moving things through the process. Okay. We have this when you guys come back, I'll show you in the lab. We have one of these for all the labs that have to be set up for the week. And it's got what needs to be done and who's going to do it and how it's going to move along. It's not on Post-it notes, it's on a whiteboard. Okay, an andon is a visual cue. Okay, so these are Japanese terms. Okay, so the Japanese have perfected manufacturing. Ford was considered the best at it. So when they were making cars, but then the Japanese and Toyota took it over and they made it even better. Okay, so visual cue. So this is like you're running out of oil. Okay, so visual cue that's going to come up and say, oh, look, you need to do this now. Okay, Hijunka is leveling workload to reduce bottlenecks at workstations. So we want to have production equals consumption. So you don't want to have a backup. So like if you were building a car, you don't want to have 10,000 doors sitting there, but you're only making 3 cars or something. Okay, so the idea is that small lots are going to be more efficient. You want to try to reduce bottlenecks. We have a lot of bottlenecks in teaching labs. We stand around all the time waiting for balances and things like that. Okay, so the idea is that the managers are going to be able to come in and they're going to be able to see it. And an efficient workplace that's working well is that all the employees are coming in and they're going to have input into the process. Okay, another technique for an efficient workplace is called a 5S. So the goal is to reduce waste and optimize productivity and keep the workplace organized. So the first step is sort. So you organize it, then you set it in order, and then you keep it clean and you standardize it. Okay, and then you have to sustain it. Okay, and then some places put in safety into that too. So that's 5S. Other things that they look at is they might look at a spaghetti diagram. So it traces movement in order to design things in a smart way to minimize movement and save time. So this is probably how our lab functions, where we're running back and forth all the time. Oh, God. Okay, but if there is definitely a better way to set it up. Okay, so lean improvement. So Kaizen is a quick process. A Kaizen event is where they come in and teams come in and they look at a process and they say, oh, look, we can do, if we change this, this is going to be better. Okay, so it's small changes for better. So it's kind of like an event where they come in and they look at it and they try to improve something. Okay, now another name of an operational excellence strategy is Six Sigma process. Okay, so the goal of Six Sigma is to reduce process variation and have Six Sigma level of control. Okay, so if you took statistics, you're going to remember that sigma is the standard deviation from the mean. Okay, so we want to be in control within 6 sigmas. So we don't want a lot of difference from the mean. Okay, so if the process is not producing a consistent product, then it's considered out of control. Okay, you got to go in and fix it then. So it's quality management. So it uses statistics. So if we're within 6 sigmas, we should only have 3.4 defects or mistakes, right? For a million opportunities. Okay, so here's 6 sigmas, right? So here's the mean, 1, 2, 3 on this side, 1, 2, 3 on this side. I put it in there again. Okay, so the idea is the mistakes that you have are going to be out here, right? So they're going to be very rare. Okay, so process variability, I put this in here. So I was trying to get you to see that if something is in control or out of control. Okay, so if you put a narrow car in a wide garage, you're going to be in control. A wide car in the same garage, probably going to be in control. But if you try to put a semi truck in the same garage, you're going to be out of control. Okay, so the idea is that you need to be in this frame to be considered in control. Don't worry about this. Okay, so in control, so here's a graph that they're in control. Okay, so the lower limit and the upper limit in the process is actually within it. And this one, the lower specification limit and the upper specification limit, and we have some things out of control. Okay, now 6 Sigma, when they want to try to gain control, they use this thing DMAIC, okay, is the acronym. So you want to define the problem, okay, so that you can be more in control. You want to collect the data. You want to analyze the data and figure out what's causing the problem. And then you want to try to improve. And then you want to maintain control. So you want to make sure that after the boss quits looking, that you continue doing it the way that you designed it. Okay, so define You can use a flow chart to examine the process. Then you're going to measure it. So you want to use sampling techniques to collect the data. Okay, so there's all sorts of statistics that could be used. You could just use descriptive statistics. You could start looking at where the variation is coming from. Sometimes they use these things called fishbone diagrams. So a fishbone diagram, so we're trying to figure out why is dinner burned again, and all the different things that could go wrong. So usually when there's mistakes, there are 4 things that could cause it. Okay, so manpower, materials, methods, or the machine. Okay, so the person could do it, the materials could be messed up, the methods, you're not following the recipe right, or something's wrong with the equipment. Okay, now there's different types of analysis and results that are going to be used to make control. So I'm not sure, this is Italian term, Pareto analysis. So it's a statistical technique in decision making used for the selection of a limited number of tasks that produce significant overall effect. So the idea is that it's the 80-20 rule. So 20% of the work, you can generate 80% of the benefit of doing the job. Okay, so 20% is going to generate 80% of the benefit. So that means that the mistakes might occur in that 20%. Okay, then we want to improve. I don't know why these are, when I bring in these PowerPoints into this program, they're looking messed up. Okay, so we want to improve human error. So if a lot of the mistakes are coming from manpower, if somebody's not paying attention, then we need to improve how they're making mistakes. We want to keep them from making mistakes. So one term is called poka-yoke. So a poka-yoke is kind of like idiot proofing. Do I have a picture of it? No. Idiot proofing. One example that I think of, and I know this doesn't always work, is at the gas station when you go to pump gas, you can't put diesel fuel into a regular, you're not supposed to be able to put the nozzle in. Okay, so it's just things that try to make it easier so you can't mess up. Okay, so operations to reduce human error. Another thing, I don't know if they still do this, but they used to do this with like computer cables and like a CPU, how everything would be color coded so you couldn't mess it up. You couldn't put the wrong cable in the wrong hole. Things like that. And I have on here, what else can you think of? So the idea is to reduce human error. When they try to improve something, okay, there are 5 general failure mode categories. Okay, so one of them is process failure. So you forgot to do it, you thought you did it, and then you went to do it again. So then you're already done it, or you're doing something too late or too early. There's selection failure. So incorrect selection, counting, calculating. Perception means you might not have understood what you were supposed to do. There's motion failure. So maybe you fat fingered something or you dropped the pipette. And then other failures, or maybe you're missing something that you needed when you went to start. It should have been a better way. So the idea behind Six Sigma is that the team is going to work together and come up with a creative way to stop people from making that mistake. And then when they control it, the idea is they're going to go and they're going to look at statistics in the data and make sure that they're not regressing or something. The change didn't cause a new problem.